All right, so let's talk about carboxylic acids and esters. So write the IUPAC and common name for the carboxylic acids and esters. Draw the condensed structural formulas when given their names. Sound familiar? It should. We've been doing it all today, so let's keep rolling. All right. In carboxylic acid, the carbon atom of the carbonyl group is attached to the hydroxyl group, which is what hydroxyl we make the alcohols from, methanol, ethanol, personally my favorite alcohol, forming a carboxyl group, okay? And I think I was using the word carboxyl last lecture for carbonyl, and I apologize. I think I corrected myself later on, but anyway, yes. So we've got our carbonyl group right there, and we've got our hydroxyl group right there. Okay, excuse me, our hydroxyl group right there. And so we've got this combination that can look like this, or it can look like this. Remember, implied carbons for shorthand, huh? Or it could even look like this, all right? So these are our ways of demonstrating this in propionic acid, all right? All right, so to name a carboxylic acid, the IUPAC name replaces the E in alkane name with oic acid, okay? Substituents are numbered by counting the carbon as the number one carbon, just like we did with the ketones and the aldehydes, okay? Common names are used for carboxylic acids with 4 or less carbon atoms because they're common, okay? So we've got methanoic acid, 2-methylpropanoic acid. Well, why is it methyl? Well, we got a methyl group right there at the 2 location, and prop, 1, 2, 3 carbons in the backbone. And then we have 3 hydroxybutonic acid, okay? So carboxyl group, right? It gives us 1, 2, 3, 4. That gives us our butonic, and our hydroxyl group, OH, right there at the 3 location. So the sour taste in vinegar is due to ethanoic acid, also known as acetic acid. Now, I believe you guys did a lab where you actually measured the amount of acetic acid in vinegar. And if I remember right, Lisa was telling me that it was supposed to be 5% acetic acid or something like that, but it was actually coming in much lower, which is kind of crazy because if you think about it, if it was in a process of evaporation of the water that it was in, the acetic acid content should have gone up. So it kind of makes me wonder if, because I heard you were consistent on it, if the manufacturer was kind of out of specification with it. It's something to think about. But, only chemists are going to be able to test that, or you guys, because you are practicing chemical students. All right. So here are some common names for the compared to the IUPAC names. So we've got methanoic acid, which is also known as formic acid. We've got ethanoic acid, which is known as acetic acid, and that's vinegar right there. All right, we've got propanoic acid, also known as propionic acid, and then butonic acid, which is also known as butyric acid. So common names versus the IUPAC names, okay? So, the carboxylic acid of benzene is named benzoic acid. Well, it's because we've got a carboxyl group, right, on a benzene ring, right? We know these benzene rings, okay? So if we look at this, it's 4-aminobenzoic acid, all right? Well, 4-amino. So we've got the amino grouping down here, and we've got our carboxyl group up here. And then we've got 3,4-dichlorobenzoic acid. So 3,4-di, meaning 2, chloro, 2 chlorines at 3,4 position. Benzoic acid, benzene ring, we add oic to the end, benzoic. So let's identify the longest carbon chain and replace the E with the alkane name with oic acid, and then give the location and name of each substituent by counting the carboxyl carbon as 1. So that's where we start. So if we start here, how many carbonates? So we got carbon 1, 2, 3, 4, right? 1, 2, 3, 4. I know that's not lined appropriately, but whatever. Here we've got, they're at 1, 2, 3, 4, and then 5. So let's see, what are those names going to be? What do we think? All right, so we've got butonic acid. Would that make sense? 1, 2, 3, 4. Bute, 4. Yep. Okay, great. And then we've got benzoic acid. Well, benzene ring, right? So that makes total sense. And then we would say 3-chloro, okay, because we got our chlorine at 3 location, okay, 1, 2, 3, benzoic acid, and then 1, 2, 3, 4. This would be just butonic acid because there is no other atom, like chlorine or fluorine or bromine coming off of that, no other halogen or whatever else might fit there. All right, so how is this linked to health? Okay, so during glycolysis, the molecule of glucose is broken down into 2 molecules of pyruvic acid, and actually it's carboxylate ion pyruvate. Okay, during exercise, pyruvic acid is reduced, giving lactic acid with a lactate ion. All right, so the burn you feel, all right, when you're lifting or running or whatever, is actually this whole lactic acid that you're feeling through your muscles during this conversion process. All right. All right. In citric acid cycles, also called as Krebs cycle, di and tricarboxylic acids are oxidized and decarboxylated, loss of CO2, okay, to produce energy for cells. So this is how energy in our cells are getting rolling, okay. So energy expelled, carbon dioxide coming out, and hey, does that make sense? Well, what does our red blood cells pick up on the way out? Drop off to our lungs so we can expel it. Carbon dioxide, right? That's a whole cycle of us breathing, all right? And we want to get rid of it because we want to grab more oxygen for more energy, all right? So we got succic acid, fumaric acid, malic acid, oxaloacetic acid, all right? Citric acid cycle continues as ketogluaric acid loses CO2 and gives a 4-carbon succinic acid, which is then converted to an oxalic acid through a series of reactions. But our body is producing this. This is what makes us function. All right, let's talk about esters. Esters are formed from the reaction of carboxylic acid and an alcohol group, okay? They have an alkyl group attached to the single bond oxygen atom and are found in aspirin, which also has a carboxylic acid in it. So we've got ethanoic acid, we've got methanol, also known as wood alcohol. We know why. It was part of poor distillation of wood as a byproduct during that process. Somebody asked me today, and we looked up, and that's what's going on. I knew it was called wood alcohol. I just couldn't remember why it was called wood alcohol. So we've got these two that combine heat methyl ethanate or methyl acetate. Okay, is what it breaks down into, and then our H2O. Yes, H2O. All right, so butonic acid reacts with methanol and acids catalyst to produce methyl butanate, an ester found in many pineapples. Okay, so butonic acid, methanol, methyl butanate. All right. The name of ester has 2 words. The first word comes from the alkyl group in the alcohol. The second word comes from the carboxylate part of the carboxylic acid. Okay, so this would be methyl acetate or methyl ethanoate. Okay, methyl acetate, methyl ethanoate. All right. So, IUPAC common. Okay, so we got ethanoic acid plus methanol equals methyl ethanate. All right. So, from carboxylic acid, okay, and from the alcohol grouping. All right. So let's take a look. All right. Common. Okay, and esters are used a lot for flavors and smells, and they can be replicated. We talk about scratch and sniff. We talk about the aromatics. Well, esters fall into this category. So, propyl ethanate, okay, found in pears. Pentyl ethanate, found in bananas. Octyl ethanate, found in oranges. Ethyl butanate, found in pineapples. Pentyl butanate, apricots. All right. So let's write these names. Okay, we changed that ic acid in the acid name to 8. All right. So we got to start looking. We got to start counting, right? All right. So first step is write the name of the carbon chain from the alcohol as an alkyl group. Well, we'll go methyl, right? Does that make sense? Of course it makes sense. Okay. And then we change it to the number of chains. 1, 2, 3, and 1, 2, and 3. And, excuse me, 1, 2, and 3. And that gives us our propionate. So methyl propionate. All right. And it's just like that. Again, let's write down these rules, follow them, and move on from there.